Well, Olivia, you had a little bit of a taste of what it's like to work at the treatment plant. And on our next stop, Dave, we're now in the lab.
That is correct. So we actually need to know what's in the water, both when it comes into the plant, when it leaves the plant. And we have our own laboratory with a lab analyst do that. So with us is Sandy Minner, and she's the lab analyst with Improvement District number 4.
So what is your role here in the lab?
I am a lab analyst. I've been here for 7 years, and we're jack of all trades in the lab. We have to do sampling, testing, report preparation for the state, and we basically test all of the properties of water that would be important for drinking water, make sure that it's safe for consumers.
So Sandy, what type of degrees or college classes could I take to get into a laboratory career like this?
Well, it's not required, but I have a degree in chemistry. A biology degree would also be helpful. Basically, anyone with a strong interest in math and science would probably be a good fit here.
And I was just outside with Derek testing the water and the whole final process of the distribution stage. But when you get the water in here, what type of analysis do you have to do?
We do things, physical chemistry like pH, alkalinity, total dissolved solids, whether you're going to have a lot of minerals that build up on your sink. We want to minimize that sort of thing. Anything that is hazardous to health, of course, we're testing for regularly. We go out weekly to our distribution system and sample at various points along the distribution system and get samples for both microbiological testing and the physical analyses.
Well, I know in a lab there are a lot of great toys that a lot of people would look at and go, you know what, I really am interested in that, how that works. I know you've got a mass spectrometer that you guys work with and some other instruments. How about we go check those out?
Okay.
All right. Dave, we're at the other end of the lab, and who have we got with us now?
This is Paul Wegner. He's our laboratory supervisor.
We do a number of tests here to make sure that the water that we are treating meets or exceeds federal and state regulations, and we have a number of instruments that we use to accomplish that. Ion chromatograph, and this instrument is used to measure analytes such as chloride, sulfate, nitrate, nitrite, fluoride, things like that. And so those are some of the inorganic anions. And then we have an instrument right here. It's called the atomic absorption spectrometer, and it measures metals. And it has basically 4 different ways of doing that. This particular method would be measuring things like magnesium, manganese, that sort of thing. And a sample is introduced through an aspirator tube. This is just water right now. And you can hear the change in tone there, so you know the sample's going in. This happens to be a calcium carbonate solution, and I'll show you what that looks like when it's introduced into the instrument. Have a nice reddish orange. There are lamps that emit a specific wavelength going over and through the flame. As the sample is introduced, energy is emitted from the electrons in the analyte that we're looking for, and in that way we're able to measure the intensity of the peak. Again, looking at that peak, we're able to use the calibration curve previously put in, and we can get the concentration of our analyte that we're interested in. This particular instrument is used to measure disinfection byproducts, and those are components that are formed when total organic carbon comes into contact with strong oxidants like chlorine. And we also use this instrument to measure pesticides.
With this whole mass spectrometer system, what exactly does it do? I mean, there's a ton of stuff over here.
This is all one instrument right here from that printer to here. So we have 2 automated samplers. This one introduces volatile organic chemicals. And this one introduces taste and odor compounds. They're both going into the gas chromatograph, and then inside the gas chromatograph we have columns. These particular columns are hollow. All the compounds come in at once. They are hopefully separated and delivered into the mass spec one at a time so we can measure the intensity. And then You will come over here, and the operating system is able to measure both by the mass of a compound and the area of that peak. We're able to quantitate the concentration through a calibration curve that was previously analyzed.
So after looking at this compound table and everything that you have to measure here, what do you find most interesting about working in this lab?
You know, I like the analyses. It's a challenge, especially at the levels that we are measuring. We're looking, I know that sounds kind of odd, but we're looking to see how little we can see, where in some labs, one that I came from, we were concerned about how much we can see, but this is drinking water, so it's very low-level analysis, so it's a challenge because the instrument has to be running very well to get to those lower detection limits.
Over here we have the 1 megawatt facility. Throughout the course of the day, it generates electricity. Over the course of 2014, we generated 1,660,000 kilowatt hours. So treated water actually uses considerably less. We're looking at about 900 kW.